So, guys, very good afternoon. This is Piyush Khandelwal, and I welcome you all to your own channel, which is Geeks for Geeks. And today we are here for the mock interview, and we have Mr. Chetan with us. So we will be taking the interview of Chetan, right? So without wasting much time, if you can tell me, right, if you can tell me if I'm clearly audible and acknowledge, if you can acknowledge me that, if I'm clearly audible to you, just put hi, hello in the comment box if I'm audible, so that I can. Okay, thank you, Aditya. Thank you very much. Let me call Chetan here. And okay, so very good afternoon, Chetan. How's you?
Good, good afternoon, sir. I am fine. How are you, sir?
I'm good. I'm good, dear. Okay, so Chetan, I got your resume right, but didn't get time to go through it. It would be great if you can tell me some technical side of yours.
Okay, sir. So, my name is Chetan. I am a pre-final year student at JC Bose University of Science and Technology, pursuing my
Mm-hmm.
BTech in computer engineering. And coming to my technical skills, I find myself more inclined towards web development. And my most recent project in the web development is named as Service Fair, which is a platform to connect clients and professionals. So
Okay.
here the clients can connect to professionals and avail services from professionals. And we have different categories depending upon which we have professionals in each of the categories, and from there the client can select the category and pick up the professionals based on their previous work, like which they have done based on their previous
Mm-hmm.
ratings and all. So from there he can choose the best professional for his work.
Okay. Okay. That was great. And what technology stack you have used for develop this?
So for this I have used MERN stack. uh,
Okay.
yeah.
Okay. So, like, have you heard of MVC architecture? What is it?
Yeah, I have actually implemented the MVC architecture in it. So it is
Mm-hmm.
basically consisting of three components: the model, view, and the controller. And
Mm-hmm.
the model is responsible for the connecting with the database and getting the data from the database. And then
Mm-hmm.
with the help of the controller, it passes that data to the views, and the views uh, are actually what is passed to the browser, which are rendered to the clients. So this is about the
Okay.
architecture.
Okay. Okay. So there is one concept, right? MVP. Have you heard of it?
MVP?
Mm-hmm.
No, sir. I've not
Not
heard about it. No, sir.
okay. And REST APIs.
Yeah, I'm familiar with REST APIs. So REST API is
Okay.
stands for Representational State Transfer. So it basically is an architectural design uh, which allows us to which allows us to create websites, so that data that is sent from our website when some user visits our APIs is represented in a useful format or meaningful format. Like the various formats that are used are like JSON and XML. So
Mm-hmm.
these are some of the formats in which the data is represented, and this is about the REST API.
So what form you transfer the data from your REST APIs, right? What format did you use?
So yeah, so I used a JSON object to transfer the data from my server to the client side. So this is how the data is
Okay.
transferring
Why
from the
JSON?
server
Why
to the
JSON?
client
Why
side.
not XML?
So XML is a little difficult to parse as compared to JSON, and that is why I just used JSON to pass the data, because XML is a little, it takes a little more time as compared to JSON to parse. So that is why I
Okay.
used JSON.
Okay. So tell me, right, how much you are comfortable in data structures, Chetan? If I ask you to rate yourself on a scale of 1 to 10, right, where 1 is the least and 10
Yeah,
is maximum, how much would you rate yourself?
sir, I would rate myself somewhere between 7.5 to 8 in DSA.
7.5. That is good. Not bad. 7.5 to 8. Okay. So tell me, can you share your screen so that may I know, right? I want you to write certain piece of code. Would you be comfortable with that?
Yeah, I can share the screen, sir. So is my screen visible?
Yes, it would be. Right. Okay. Yes. So you can open up the editor of your choice, right?
Okay, sir. So I'm opening an online ID. So,
Okay.
yeah, sir. Is my screen visible?
Yes, it is. It is.
Okay. So,
Okay. So you would
like,
be using Java. You would be using Java
yeah,
for code, right?
yeah, I would be using Java, sir.
Okay. That's fine. So my question is, right, you are given an array, right? And you
Okay,
need to
sir.
find whether that array contains a duplicate element or not. What would be your approach? Let's see the approach first, then we'll see the code.
Okay. So, like the brute force approach would be to use two nested loops, and the
Mhm.
outer loop will iterate from the n minus one numbers, and the inner loop will check the frequency of every number. And
Mhm.
so, if a number is repeated, then its frequency will be greater than one, and we could find that element.
Okay.
So, for
Okay.
like the, yeah, if
And
we
what
talk
would be the
about the,
complexity of this?
yeah. So time complexity for this would be big of n square, where n is the size of the array, and the space
Hmm.
complexity for this would be if we want to find all the duplicate numbers, then it would be taking the space equal to the number of duplicate numbers. If we want to return the number of numbers that are duplicate, then the space complexity would be equal to the numbers that are equal to duplicate, that are duplicate.
Okay. Like my question was, I need to know whether the array contains duplicate elements or not, right? So
All
this
right, all.
is my question, right?
So
Okay.
for this, for this, the space
Hmm.
complexity will be constant.
Okay. Better approach than this.
So we could use a hash set or a dictionary to keep track of whether an element is previously and seen or not. So if an element is
Hmm.
previously seen, it means that that element is a duplicate in the array. So we could find it in a linear scan only. So the time complexity for that would be big O of n, and the space complexity would also be big O of n.
Okay.
And
So what you
there
will do,
is,
you will use a hash table.
yeah, we can use a hash table where we can store the frequency of every element.
Okay. And you told me that the complexity is going to be.
So we would actually be requiring only a linear scan of the array. So the time
Hmm.
complexity is going to be linear. where
Okay.
big of n only.
And space complexity?
The space complexity is also going to be big of n in the worst case. If all the elements are distinct in the array, then we would
Hmm.
be ending up entering all the elements into the hash table. So the space complexity is going to be linear.
Okay. If I give you one more condition, right? That
Yes, sir.
suppose the size of array is n, right? And all the elements in that array is going to be less than the size of array, right?
Okay.
From 1 to less than size of array, right? So
Yes.
I'm giving
Yes.
you the space also, the range also from which the array will have the elements, right?
Right, sir.
In that case, can you do better?
Sir, in that case, like uh, what we could do is uh, is there only, I would like to ask one question, like is there only a single element that is going to be repeated, or there can be multiple elements that are going to be repeated?
There could be multiple, like there could be multiple elements that could be repeated.
Okay, so in that case, what we could do is we could use the indices of the array as a way of mapping
Hmm.
the elements to their to the indices. Like what I mean to say is, like if we have the elements like 1, 2, 3, and they are
Hmm.
like present at different locations. So I'm assuming one based indexing. So what I'm mean to say here is that the three, I would place all these elements to their correct positions, and I would what is the correct position? It is actually the index of the array. So at the first index, I'm going to place 1, and at the second
Hmm.
index, I'm going to place 2, and at the third index, I'm going to place 3. And
Right.
uh, after doing this, I actually have placed all the elements at their correct positions. Now, whichever
Hmm.
element is whichever element is not present at its correct position, that element is actually repeated. For example, let's take another example like 3, 2, 1, and 2, and 3. So the element would be placed like this. So now this last 3 is not at its correct position. So that is how we would be knowing like this element is repeated, and uh, the array contain duplicates.
Can you
So
write the
like
code for, like, first you tell me what is going to be the complexity of it?
So for this, the complexity is going to be linear only, because we are going to
Hmm.
place the elements in the array, and the
Hmm.
space complexity is also constant in this case.
Okay. Can you write the code for this?
Yeah, I can write the code. So I'm actually making a function
Hmm.
that is going to return a Boolean value, whether uh, uh, which will tell us whether there is a duplicate in the array or not. So here we
Right.
would be given an array, and and which will denote the size of the array. So like uh, what I have to do here is uh, I can take a pointer which will scan the entire array. So I initialize it with 0, and while I end up scanning the entire array, what I'm going to do is I'm going to check if the current index, if the element at the current index is equal to AI or not. So if it is not equal, then I'm going to place it at its correct position. Like here, 3 is not at its correct position. So I know what is its correct position. So whatever element is present at that position, I'm going to place it over here. And then I'm going to place this element at its correct position.
Okay.
Let me just think about it. So if 5 plus 1 is not equal to AI, then let me hold this in a temp AI, and then AI would be equal to uh, A of temp minus 1,
Mm-hmm.
and A of temp minus 1 would be equal to temp. Uh, Let me just see if it is working fine. I0 and 1 is not equal to 3. So what we did in the temp we stored 3, and whatever element is present at the second index, we placed it at the first position. Then we have 2, and then at the temp minus 1 we place 3. Yeah. So after this, what we are going to do is, now the element is placed at its correct position, and
Mm.
here we are actually not going to increment a pointer, because uh, we might encounter the same element again,
Okay.
like 3 and 3 again. So for that we also need to keep track, because we might end up in an infinite loop. Let me think about it. But if it is like equal to this, then we are going to increment I, and it will serve the
Tell me one thing.
purpose.
Tell me one thing, Chetan, over here. If the
Yes, sir.
elements are already at correct position, right? They are. I'm giving you already in sorted order: one, two, three, four, five. What you will do in
Yeah.
that case?
So that is what I need to try. That is what I need to handle in the line number 13, whether I would have to increment I or not. So what I can do
Hmm.
here is, if AI is now equal to I plus 1, so then I would increment I. It means that the elements are already present at their correct position. So I would increment the pointer to point to next value.
Okay.
So
And
let
when would you
me.
declare that it contains duplicate?
So for that, I actually need to do a linear scan again. Uh, for this, I would have to. Uh, I can reinitialize that, and then I could do. And if uh, there is some element that is not equal to AI, then it means
Hmm.
that this element is repeated. Then from there I can return uh, that it contains duplicates. And otherwise
If I
I can
plus one
return
is not
false.
equals to AI,
It means that there is a duplicate. So because I already placed all the elements that were equal to AI at their correct position in the previous while loop. So here I am checking if there is any element that is not equal to that index, then it means that this element is repeated in the array. Actually, let me do a dry run with it. Then it would
okay.
be more clear. Yeah.
Hmm.
So let's take like the array 3, 2, 1, 3. So initially I is 0, and uh, 1 is not equal to 3. So what we did, we hold this value 3 in the temporary variable, and after this,
Hmm.
whatever it was present at the second position, we placed it over here. So now our A0 becomes 1, and our A2 becomes 3. So now the array becomes uh, 3, sorry, 1, 2, 3, and 3. And so now I also check this condition if AI is equal to I plus 1, right? So here the A1, A0 is equal to 1. That is, this 1 is
Hmm.
equal to this index. So I incremented I. So now I is pointing at the second index. Uh,
Hmm.
that is at the first index and the second position. So now this element is actually at its correct position. So I came in the else part and I incremented I. So
Okay.
I now points to second index. So I again check this condition if I plus 1 is equal to AI, not equal to, but
Hmm.
again this is equal. So we came in the else part. So that is how we incremented the index to point to the third position. So now it is not equal, and
Hmm.
so we entered in the if case, and in here we in the temp we have 3, and whatever is there at the ith index, that is also equal to 3. So a of 3 is also equal to 3. And again
Yeah.
what it is doing is it is updating a of 2 to equal to 3. And
Hmm.
I have actually checked that condition if ai is equal to I plus 1, which is there. uh, Actually yeah, I think a3 is equal to, actually I have to check this condition if a of temp minus 1 is equal to temp, because that is what is repeated here, I think.
Temp minus 1 equals to temp won't work.
Okay, let me just think about it.
You were going right, right? You were going right, but one condition is missing, still missing.
Yeah, so at the line number 13 I think the condition is wrong.
Hmm.
So here I think we need to check it somehow. If the position at which with which we are replacing it, if that is equal to this, then we do not actually need to swap it.
Okay.
Yeah, I think the value at a of temp minus 1, I think we can actually test it earlier also in the beginning. If that is equal to AI,
Hmm.
then we can simply skip this part and we can increment it. Like if like in this case, like at the third index, if the value what is the value at the third index, this is 3, and this is
Hmm.
also matching with its correct position where it should
Right.
present. So that is why we will increment I, and now I will be pointing to the end of the array and we will come out of this while loop. Is that fine, sir?
Okay. Let me check whether what case. Can you try it, run it for like 1, 2, 3, 4, 5, right?
Yeah.
How it will work? It will always go to else part.
Yeah, it will always go to else part and will increment I. And in that
Hmm.
case, uh, we will simply, since all the elements are at their correct position, so we will simply come out of this while loop and we will check here if
Okay. Tell me
I
one thing.
plus,
Tell me one thing.
yeah,
Do
yeah,
I
yeah.
really need this second loop traversal for telling that whether array contains duplicate or not? When I was doing this swapping thing, right? When I was checking this thing, can I make sure at this time only that array contains duplicate?
Sir, I think
Why do I
that
need
that
why do I need this second loop, the second traversal?
sir, actually in the second traversal, what I'm doing is I'm checking if any element is not present at its correct position. That means it is
Why
duplicated.
can't why can't this be done in the first loop only when you are placing all the elements their respective position? If that element, the same element, you are again founding it,
Yeah.
right?
Yeah, yeah, yeah.
Can't.
I think we can do it at line number 11.
Mhm.
if the element is like already, if like whatever element is present, if they are present at their correct position, then
Hmm.
we can say that we have found a duplicate element in the array, and from there only we can return false. I think from here.
Exactly, right? We don't need this second loop to tell.
Yeah, yeah, absolutely, sir.
I hope you
So
got the
from,
idea, right?
yeah, yeah, from there itself we can return false, and otherwise, like I can comment it. Uh, from there itself we can return true because we found a duplicate, and
Hmm.
otherwise we can return false if the array doesn't contain any duplicates.
Right.
Yeah,
So एक बार और try run करेंगे, like can we do this once, right? For one
yeah.
example, suppose you are given a number one array 1 2 3 1 2 3. How will you do it for that?
One,
Will
two,
this work?
three.
Yes. Yes, 1 2 3 1 2 3.
Okay. So for this, let me just mark the indices 4, 5, 6. So firstly, we will check if I plus 1 is AI. So since it is equal to AI, so we will come to the next pointer. We will increment our pointer,
Okay.
and now our pointer is at second position. Since it is
Mm-hmm.
also equal, so now we are at third
Hmm.
position. And
Right.
now when we are at fourth position, I plus 1 is not equal to AI. So in the
Right.
temporary variable, we have AI, which is 1. And actually, at a of temp minus 1, which is 1 minus 1, here we have the same value, that is 1.
Hmm.
So that is why we can simply return from here itself that we have a duplicate element in the array. So that is why we will return from here only.
Okay. Okay.
Yeah. So basically, it is checking whether the position at which this element should be present. If an element is already present at this position, it means that we have encountered a duplicate. So
Exactly.
that is
So
that is
this
how
will
we, yeah.
give, what would be the complexity of this now?
So the complexity is big of n only, and the space
Hmm.
complexity is constant.
So if I tell you that array contains only one duplicate, and again the
Okay.
same condition, array size, the array elements will be less than the size of array. What will we do in
Yeah.
that case?
So in that case also this will work fine, but if you want me to come up with a different approach, then I can
Hmm.
think, yeah.
I
So
know this
if,
will work fine, right? If we could find out some easier solution, because we are like we are given one more condition, right? It
yeah,
contains
yeah, yeah.
exactly one duplicate.
Okay. So in that case, so what we could do, we could use the XOR operator. So since we know that the XOR of same quantities is equal to 0, so
Hmm.
what I can do is I can do a quick linear scan of all the numbers from 1 to n,
Hmm.
and I can store that in some variable by doing XOR of all the variables from 1 to n.
Okay.
And after that, I will do the XOR with the elements of the array, and whatever element I have, whatever is the result of this XOR value after scanning the array, this will tell me the repeated element. Like,
Okay. So what will you
yeah,
do? You will do the XOR of
all the
all the
1 to n.
elements and XOR of 1 to n.
Yeah, yeah. So how this will work is like all the elements that are present one time in the array, they are actually now present even number of times in both the operations. After doing both the operations, so they will actually reduce their XOR to 0.
Okay.
So like if we XOR two similar quantities, then their resultant is 0, right? So, and if we do anything with, if we do the XOR of any other number with 0, then that gives us that number. So this is the idea that is used. and
Okay.
like whichever element is repeated, it is present odd number of times. So that is how we will find it.
Okay. Okay. Good. Great. Chetan. Let's move to next question, right?
Okay, so
So you are given a number A and I want to convert this to number B, right? So I'm giving you two numbers.
okay.
Suppose I'm giving you 10 and B is 20. So I want to convert 10 to 20. How can I do that?
So like we can check if the whatever is the, like we can add some number to that, or
Hmm.
subtract some number to from that. Like if the number is greater than the number which we want to make, then we can
Hmm.
add whatever is the difference between the two numbers, and otherwise
Okay.
we can see.
Now if I
Yeah.
need to tell you how many bits, minimum bits needs to be toggled, changed, right? To convert A to B.
Okay.
Can you tell me this?
So the binary of 10 is like from A to B. So okay, let me think. So I think we can find the binary representations and can check if we could do something like whatever is the bits that we need to change.
Okay.
Let me like the binary of 10 is 1010, and
Right.
the binary of 20 is this is 4 8 16. Yeah, so this is a binary of 20. So
Hmm.
from here I can check like at the corresponding positions, if the bits are same, then I don't need to change them. If they are different, then I need to change them.
Right.
So from there, yeah. So from there we can know like how many bits we actually need to change. Um, am I audible, sir?
Yes, yes, you are audible. So what will you do? Like how will you do it in program?
So I will actually find the binary representation of both the numbers, that is A and B. And
Okay.
after finding the binary representation, I can check like if at the corresponding positions, if the bits are same, then I would not count it. Otherwise, if the bits are different, then I could I actually have to change one bit. So I could find out.
Okay, so you will convert the number into binary first, right?
Yeah, yeah.
But numbers are already represented in binary, right? Why do I
Yeah,
need to convert them?
yeah, yeah. They are already represented, but I was saying that we would get this representation somehow. Okay,
What will be the
I got your
complexity
point.
of the
Like you are,
solution? What will be the complexity of the solution according to you?
so the complexity is going to be big O of the log n, where n is the number, and actually it will be equal to the uh, size of bits that are actually used to represent that number. Like if it is an integer, then it will be 32 bits.
How many bits are needed to represent the number? Like how do you what
Like if it is an integer, then 32 bits are required to represent that number. Like in Java, it is 32 bits,
are you sure?
and if it,
Are you sure? How many bits are needed to represent 10?
so for like I am talking about the like the maximum number. So for that we require 32 bits. For 10 we only
Okay.
require four bits.
So your complexity will depend on the number of binary bits representation. Na?
Yeah, yeah, that will be actually equal to the number of bits in the maximum number of bits in the binary representation of any of the numbers.
Okay.
So
And
yeah.
so what is the maximum number of bits? How we figure out the maximum number of bits to represent a number in binary?
So that is given by log n base 2 plus 1, I guess. The seal value
Yes.
of log n
So
base
so
2 is
that
that.
is going to be the complexity, right?
Yeah, yeah. That is what I thought.
Yes. So the complexity of your solution will be
So it is big of log n base 2.
okay. And then you would be traversing this. You need one traversal also, right?
Yeah, we need one traversal to find if the corresponding bits are same or not.
Okay. Any better solution than this? I want
Okay,
to do it in big O one.
okay, okay. Let me think, sir. So here, like for tan and 20, what I can do is I think what I can do is I can do the XOR operation. So
Hmm.
whichever bits are same, uh, the XOR of them will be 0, and whichever bits are different, the XOR of them will be 1. And then I can count the number of set bits in the resultant of these two numbers, like the resultant XOR of these two numbers.
Okay, let's write the code for this first.
Yeah, sure, sir. So I'm making a function, and it will return us the number of different bits in two
Hmm.
numbers, and we can do a XOR of these two numbers, and then I just need to count how many bits are set in both the numbers. So I am initializing a counter which is initialized with 0, and then so actually there's an algorithm like uh, which checks this in uh, how many bits are set in the we go of the number of set bits in both the number in the number. So what it
Okay.
does is
And
it
what is the name of that
actually.
algorithm?
So the name is actually I'm not familiar with the name, like, but how it works is like it removes the least significant set bit from its
Hmm.
corresponding position. So what we do
Okay.
is yeah, let me show it in the code itself. So while the XOR is
You
like
write
greater
the
than.
code for it, right? Yes.
Yeah. So while the XOR is greater than 0, we will implement a counter, and we do the XOR. We update the XOR with the bitwise end of XOR and XOR minus 1, and finally we return the count, like whatever is the count. So what this is actually doing is like, if I have to talk about this example, so the bitwise end of XOR and XOR minus 1. So this is actually removing the last set bit. So this is what it is doing. So this
Okay,
bit
tell
is
me one
removed.
thing. Tell me, I got the idea. I got the idea. Right. Tell me
Yeah.
one thing. You have put the brackets around like XOR minus one, right? If I
Yes.
remove them, will the solution work again or not?
So actually, that depends upon the priority. So I think the solution will work because bitwise AND is having less priority as compared to a subtraction minus operator. So
Sure.
first of all this subtraction is performed, and after this the bitwise AND is going to be performed.
Are you
Sir,
sure?
like I'm not 100% sure, but I think like I think like the minus is having more priority as compared to bitwise end,
Okay.
but I'm not 100% sure. I need to actually check.
A computer
So
should
that is
also think the same, right? The compiler should
yeah,
also think the same what you're thinking. Then only it will work.
yeah. That is why I placed a bracket to increase its like
I just wanted to know whether you know the
precedence.
precedence or not, right?
Yeah.
Okay.
So yeah. So this will change the precedence of like this bracket operation will be performed first, and then we will do a bitwise and with the XOR.
That's fine. Okay, this will work, right?
Yeah, this should work.
Okay, so we still have right 20 minutes more, right? Or what we can do is I can ask you one more question. So would you like a DSA question or some question from your projects?
So as you wish, I think we can you can ask me a DSA question. That will be great.
Because projects I have copied, right?
No, 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 they are not copied.
Okay. One project that you have made is algorithm visualizer, right? So, whoa,
Yeah,
sorting visualizer.
sorting
It is
visualizer. Yeah,
sorting visualizer, right? So I've
right.
seen so many sorting visualizers. How your sorting visualizer is different from the ones who are present in the online, the people have developed.
So actually, this project was made to learn the React.js concepts and the
Okay.
animations in React.js. So that is why I built it. And the
Okay. You built it on your own. Can I see? Can I see how is it working?
yeah, I can show you. Like I have to actually open my resume first. So, sir, like if we want to generate a new array, we can generate that.
Mhm.
And like if I click on the merge sort, so this will start merging the array. Like initially the left half is merged, then the right half, and then finally it will give us the sorted array. So if you want like quick sort, so it I have actually chosen the last element as the
See,
pivot.
all the visualizers, Chetan, I want to stop you here, right? Because all the visualizers I've seen, they do it this way only, right? I wanted to see something different, right? Where you are telling that how the steps are working, how the code is working, where the piece of like by seeing this visualization, how can I figure out, right? How can I figure out how the algorithm is working? It's like you click the button, it's sorted on its own, and I see the after results, right? I see the data is sorted. How it is
Yeah.
helping me to learn the algorithms, how it is helping me to determine the difference between the algorithms.
So actually, as I mentioned, like it was just to learn the concepts of React.js and the React framework animations. So that is why I built it. I did not build it for the purpose of like allowing anyone to learn it. Like so
But
that
do
was
it
the
right, do it, Chetan, right? Let it
yeah,
modify it in a way. You need to modify it in a way so that it helps others. Your project should not be for the localhost deployment only. I've done it, I've learned, and it's done. You should be building a project so that it can be used, it can be of some use for others as well,
yeah, yeah,
right?
sure, sir.
So
Like
do it
what
in
I
that way. Like it's my suggestion for you. Modify it so that it can help others to learn sorting algorithms. It is a
yeah,
simple sorting visualizer as like hundreds present already present on GitHubs, right? It is same as that.
yeah. So I can also show you like the other project which I made recently. So
Okay, okay. Let me talk something about it. Right? Can you
yeah,
see this? Okay. So you have implemented merge sort, quick sort, selection sort, insertion sort, right?
yeah, sir.
Which sorting
Yeah.
algorithms are stable sorting algorithms among these?
So actually, the mud sort and this mud sort is a stable one. Quick sort is not a stable one. So, but we can
Hmm.
like make the unstable as stable ones also by doing some modifications. But so heap sort is also it's an unstable algorithm, and the selection sort is a stable algorithm. And if you talk about insertion sort, so here we compare the element with the previous element. So
Hmm.
it is like in the case of equality, if two elements are equal, then they are not swapped. Like whichever element is appearing earlier, it is there in the it is present first. So it is also a stable algorithm.
So you told me insertion sort is stable. You told me merge sort is stable.
Yeah.
Merge sort is stable, pakka.
Yeah, merge sort is stable. So because when the elements in the left side, left half are same, so we
Hmm.
actually copy it from the left half only, and we increment the
Okay.
left pointer to point to the next position. That is why
Good.
it is
Good.
stable.
Great. That's fine. That's fine. Okay. So that's all from my side, Chetan. Right now, I think it's done. Right. Any
Yes, it
questions
is.
you have for me?
So like I have like only I would only like to ask like if you could suggest some uh, improvements that which I can do, and like the feedback.
So I have few feedbacks, right? I have few feedbacks that I would love to share, Chetan.
You
Right?
should most welcome,
Okay.
sir.
And
Yeah,
this is the best part where you should be noting those points, right?
absolutely, sir.
Okay. So Chetan, let me remove this, right? First thing is that you are very calm, right? You were not so nervous. You were answering the questions very politely, right? And I really love the way that you were handling the questions, answering the queries. You were stuck at certain points. Still, like I couldn't see those lines at your forehead, right? So that was the best part. I loved the way you like this whole session was conducted. That was a so I love the interaction of yours, right?
Thank you
So
so
that
much,
was
sir.
the
Yeah,
first part. After that, when I see, you might have also realized this thing. The questions were not very difficult, right? I asked you the basic questions, but keep on
yeah,
changing those questions as you were able to answer them, right? So why I did that? Because I wanted to know, right? Because there are certain times when we know the solutions for some situations, right? But if the situation is changed at the time, how you are going to respond that, right? I know the solution for one problem, right? But if that
yeah,
problem is not presented in that way, it is presented in some other way. So if that I've crammed that solution, if I have just do the stratification, then it would
yeah.
not be possible for me to give the answer for those molded questions, right? So that's why I asked one question, keep on molding the same question. With that, with that you can actually verify the genuine learning of the person, right? And you were truly right. You stand uh, uh, to that mark, which I was expecting. Okay,
Okay,
so
sir.
because because that shows that you have good conceptual knowledge. That's why you are able to answer the changed question or the molded question, right? That was the good part of yours, right? And tell me honestly, right? From
Yeah.
where did you get that Zor XOR wala idea? When I was asking you this bit questions, right? So you read
Yeah.
the chats.
No, 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 no. Actually,
Okay.
I didn't write the chats. Actually, uh, I
Hmm.
just applied the property only. Like I thought
Okay.
in it in some way, like XOR operation does this, so we can use that property.
So you thought it on your own.
Yeah, actually, I was also having a different approach of finding the sum of n elements, because we know the sum of first n natural numbers, and then
Hmm.
subtracting that sum from the array elements. So somehow I
I was
like,
not. I'm not talking about the array question, right? I was talking. I'm talking about converting A to B.
yeah,
There
so
you were
that I
first. You were saying that I will be doing the binary representation. You were stuck with that.
yeah.
You were saying that I will be doing that, but suddenly you realized that I can do XOR, XOR as well. So
So
how did
actually,
you get the
yeah.
idea?
So I actually observed it from the 10 and 20 pattern, like the example that
Okay.
you gave me. So I actually observed that pattern, like if we can do that, do the XOR, and the same bits will be off, and the different bits will be on. So if we can
Okay.
count the number of different bits, so that's how I got the idea, and I just told you that.
Okay, that's fine. That's fine. So why I wanted to know that because you were uh, stuck to the point, right? I will do the binary conversion. I will then count the bits. But suddenly you made the solution, right? That I will do XOR. When I told you that I have to do, we have to do it in big O1,
Yeah,
right? So I thought at that point that you read the chat, so you got idea from somewhere, right? But still, when you are able to see, it does not make any difference to me whether you because when you are working in the company it is not possible for you to know the every solution, but if you can
yeah,
google the solution and can code them right correct way, so if I can look for the solution, okay, and what I need to write the code. If so for me, if you have read the chats, got the idea from the chat, but you implemented that's enough for me, right? That is what I
yeah.
wanted to know, whether you can implement the idea or the suggestion correctly or not. Okay. Okay, that's fine. So, like it was a good interview from my side, right? If I would have been the real interviewer, definitely I would have moved you to the next round. And with that, I wish you all the luck. And okay. So, guys, meanwhile, before finishing this, let me tell you that if you want to appear for these mock interviews, description is in the link. I hope you loved today's session. You got some idea, right? How you can also how you can also be benefited from these sessions. Okay. Can you please type "We love GFG" if you really love the session, right? Can you type "We love GFG"? I love GFG, so that may I know that you love the session. Okay. Meanwhile, Chetan, it was nice interacting with you.
Thank you so much, sir. I actually learned a lot from it. It was a
Okay.
nice experience to get interviewed on GFG, sir.
Okay. And I wish you luck also, Chetan, for your future interviews that you appear. And definitely you will crack a good company. You have good knowledge. Wish you luck.
Thank you so much, sir.
So, guys, let's finish up the session with okay. I'm getting a lot of response, right? We love GFG. Yes, we all love GFG if GFG is helping you. And if you love this session, right? Okay. Akshay Magai is saying, I love GFG and practicing more and will surely apply for mock interview in future. We will wait for you, right? We will wait for you. Definitely will help you. Okay. Okay. We love GFG and एक बार जल्दी से type कर दीजिए we love GFG and I'll finish up this session. Hurry up guys, hurry up. And we'll come up with more and more sessions for you. Everyone, एक बार type कर दो यार फटाफट से. Thank you, Nan. I'm not getting your full name, but okay. Thank you, Yash. Thank you very much. Thank you, guys. Okay, so sir, I want to ask some questions. Some question. Don't ask some question. You can ask one question, right? I would love to answer them. Best moments, right? Okay. Can we hit 50 likes before this live stream ends? Can you tell, sir, as a beginner, how to practice GFG DSA? So, Bharat Bhushan, have you enrolled in this course? Yes, 30 years code की बात मान लीजिए and give us 50 likes. Acha, make okay. Cherry Techniques is saying make these problems available. Surely, generally what happens, Cherry, and let me tell you, these questions are not planned question, right? We don't know what to ask, right? So it happens like we interact with the students and we come up with a question at the moment. That's why. But definitely we'll try. We'll try so that we can have the links so that you can also solve it. Please remove that login pop-up. Okay, I'll ask the technical team for that. Akash, don't worry. Your point will be considered, right? So Akash, मैं बता देता हूँ, मैं highlight भी करता हूँ आपके point को, so that the technical team would be when watching this session, they will definitely, yes, yes, I got it, don't spam, I got it, and I'm showing this message over here as well. Okay, okay, thank you, and keep this love alive for GFG, and definitely will come up with better, and yes, please log in, yes, we'll do it, Mr. Robot, will do. ठीक है. Okay, guys, thank you very much, and we will join you in the next session. Thank you, guys.